Hello there, Mr. Sutton here with the IM3 Honors 4-5 Part 2 homework solutions on graphing quadratics. For this problem, we're graphing this quadratic in standard form. Since the a value out here is positive, we know this is going to open up, but beyond that, we're going to need to do a little bit more work. Let me start by getting the vertex with negative b over 2a, my vertex formula. So that's going to be negative 6. My b value is negative 6. Over 2 times 1, we have an invisible 1 out there for the a value. Well, that's positive 6 over 2, which is 3. So that's the axis of symmetry, the x value of the vertex. To get the y value, we plug 3 in for x in the original function here. So that's going to be 3 squared minus 6 times 3 plus 9. Well, this is 9 minus 18, so that's negative 9. Plus 9 gives us 0. So our vertex then is 3, 0. And I'll put that on my graph. That's right here. Now some other easy points. We have a y-intercept of 9, 0, 9 to be precise. That's that constant out there. So that's going to be, let's see here, 1, 2, 3, 4, 5, 6, 7, 8, 9 right there. And then we'll use symmetry to get another point. Our axis of symmetry is x equals 3. So if my y-intercept is 3 to the left of that, there's another point at the same height, 3 to the right here. And then draw the parabola through those points. On this problem, we see that we have this quadratic equation in standard form. So to graph this, we're going to use that vertex formula, negative b over 2a, to find the x value of the vertex. So that's going to be, let's see here, negative 12. This is a negative 12 for the b value. And for a values, we've got 2 times, we have an invisible 1 right here. So this is positive 12 over 2, which is 6. And then plugging that back into the equation for x in order to find the y value, we have 36 minus, let's see here, this is 72. So 36 minus 72, that's negative 36. But now we're adding 36 again, so that's 0. So we have a vertex at 6, 0. Now graphing that out, before we graph it out, though, let's just think ahead a little bit about the scale. Because after I graph the vertex, my next point is going to be the y-intercept, which is this constant out here, the c value, the positive 36. So my scale of going by ones is not going to work vertically. So let me make my scale go by, let me see, 6s here. Will 6s work? Yeah, let's make the vertical scale go by 6s, and I'll even make my x scale go by 2s, because why not? So we've got, let's see here, 6, 0. We're going to be going over 1, 2, 3 of those grid lines then. And then my y-intercept again is 0, 36. So that's going to be 1, 2, 3, 4, 5, 6 grid lines right there. And now using symmetry, this axis of symmetry going through x equals 6 right here, that means that if I'm 3 grid lines to the left to get 1 point, I have to go 3 grid lines to the right on the other side to get a symmetrical point. So that lets me get 3 points that I can graph my parabola through. For this one, we're trying to graph this quadratic in standard form. Let me start by getting the vertex. So negative b over 2a. So we've got negative 12, that's my b value. And then we have 2 times a, that's 2 times negative 2 for that. So this is negative 12 over negative 4, which is positive 3. Plugging 3 back in for x to get the y value. Let's see here. This is going to be 3 squared is 9 times negative 2 is negative 18. We're adding to that 36. So negative 18 plus 36 gives us a positive 18. And then subtracting 16 from that leaves me with 2. So 3, 2 is my vertex. So before I go ahead and graph this, just kind of looking ahead, I see that my y-intercept, this constant out here, is going to be negative 16. And with the grid lines the way they are going by 1s, that's going to be a pain to graph. So I'm actually going to make my y grid lines go by 2s. I think the x's can still go by 1s, but I'm going to put 2 here on one of these y-axis grid lines just to let people know what I'm doing. And so now graphing out this vertex of 3, 2, that's going to be over 3. And since my vertical grid lines are going by 2s, I'm only going up 1 grid line to graph that point. Okay, now my y-intercept, as I said, that's going to be negative 16. So let me graph that. That's going to be down 8 grid lines. So 1, 2, 3, 4, 5, 6, 7, 8 right there. And I'm going to use symmetry to get one more point. Since this is my vertex at 3, that means I have a line of symmetry at x equals 3. So if my y-intercept is 3 to the left, that means there's a symmetrical point 3 to the right over here from that axis of symmetry. So there we go for our third point, and now just graph the parabola connecting those. To graph this parabola in standard form, let me start by getting the vertex with negative b over 2a. That'll give me the x value of my vertex, or also called the axis of symmetry. So my b value is negative 6, this middle x coefficient. So up here we have negative 6 over 2 times my a value is negative 3. So this is positive 6 over negative 6, which is negative 1 if we simplify that. Let me plug negative 1 in now for x in the equation to get the y value of my vertex. So negative 1 squared is just positive 1. So this is negative 3 for that first term. But then we're doing plus 6, so that's positive 3. And then 3 plus 9 gives us 12 for the grand total on that. So my vertex is at negative 1, 12. Now this presents a little bit of a problem if you're going by grid lines that are worth 1. So to help us out here, I'm going to make my grid lines vertically go by 2. The horizontal grid lines can still go by 1, but my vertical grid lines I've got to go by 2s in order to fit everything on this grid. So my vertex, then I'm going left 1 and up. This is going to be 1, 2, 3, 4, 5, 6 grid lines to get to the actual value of 12 up there. All right, let me get some other points now. My y-intercept is going to be 9. That's this c value here, this constant, so 0, 9 for the y-intercept. And that's going to be up 1, 2, 3, 4, 4.5 grid lines, since those are going by 2s. And then I'll use symmetry to get another point, 1 grid line to the left of that axis of symmetry at x equals negative 1. So going over here to get that symmetrical point, and that's at negative 2, 9. And now I can just graph my parabola through those 3 points. For this one, I'm trying to graph a parabola in standard form here. Let me start by getting my vertex, my x value of my vertex anyway, with xv equals negative b over 2a. My b value in this case, the coefficient of x, my linear coefficient, is 4. So I have negative 4 over 2 times, and this is an a value here of negative 1. We have an invisible 1 there. So this is negative 4 over negative 2, which is positive 2. I need a y value for my vertex as well, so I'll plug this x value into the equation for x, and whatever I get back is the y value of the vertex. So this is 2 squared, which is 4, but we have a negative out in front, so negative 4. Negative 4 plus 8 is positive 4, plus another 20 is 24. So 2, 24 is my vertex. In order to actually graph that, my grid lines can't be going by 1s vertically. I'm going to make them go by 4. My horizontal grid lines can still go by my 1 here, but 4 is what I need for the vertical. Or I guess I could get away with 8. The reason I'm doing 4, though, instead of 8 or 10 or something like that, is because I see my y-intercept is going to be 20. So if I go by 4s, I can hit 24 and 20 with just individual grid lines. All right, so we're going, let's see here, over 2, up 1, 2, 3, 4, 5, 6. Grid lines gets me to 24. And then for my y-intercept, my c value, my constant here, that's 0, 20, giving me another point. So that's going to be 1, 2, 3, 4, 5 grid lines on the y-axis. So my axis of symmetry is right here going through x equals 2. That means that if I have this point over here that's 2 to the left of that axis of symmetry, there must be a symmetrical point over here 2 to the right of that axis of symmetry. And that gives me 3 points to graph my parabola. To find the graph of this equation in standard form, let me start by getting my vertex. So that's going to be negative b over 2a for that formula. Now the b value here, since your linear term is not there, that means we really have a 0 for b because you have a 0x that we're not bothering to write down. So this is negative 0 over 2 times invisible 1 here. And that all comes out to just 0. Now plugging in 0 for the x value to get the y value for the vertex back. 0 squared minus 25 is just negative 25. So our vertex then is 0, negative 25. Okay, now if I wanted to get the y-intercept to get another point, that wouldn't get me anywhere because that's also negative 25. It's just this constant here. So that means I need to do something else for those other points. You've got some options here. You could just plug in an x value like 1, and that would give you something else. But I like to find the x-intercepts because I know the x-axis is right here. It's easy to find the x-axis. Other y values might be more difficult to graph out. So let me find the zeros by setting this equal to 0 and solving. So if I add 25 and square root both sides, then I end up with x equals plus or minus 5. And now let me graph out these points. I've got 0, negative 25, 5, 0, and negative 5, comma 0. Now in order to graph these out, I'm going to have to change my scale a little bit. I'm going to make my y values go by 5s. The x values can still go by 1s, but if I make the y values go by 5s, then graphing out 0, negative 25 will be a little bit easier. So that's going to be, let's see, 0, comma, negative 25. That's going to be 5 grid lines down. And then we're going 5 to the left for that 0, and 5 to the right for the other 0. And then just drawing the parabola through those points.